If filters make your search feel broken, it's usually because you're mixing Boolean constraints with ranking incorrectly. Let's implement must, should logic plus facets so results stay relevant and compliant. You might see empty results after a strict filter, or you might see irrelevant top hits when you only boost. I will show you how to combine both worlds. You will learn to force hard constraints for correctness and apply soft boosts for relevance, all in a small Python pipeline you can extend to real data. Expect clear rules you can tune, not magic defaults. I'm Professor Pi, teaching search and IR from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. Now we start by building a tiny baseline ranking function. This snippet builds a tiny lexical ranker over toy docs. It shows the minimal pieces you need to go from raw text to a score. At the top, we tokenize documents and the query, and we compute a simple match score by counting overlapping terms. The snippet also computes a lightweight inverse document type signal, so rail terms matter more than common terms. The important lines are the index creation, the per document token counts, and the scoring loop that multiplies term frequency with the inverse document measure. This gives a baseline ranking you can inspect before adding any filters or boosts. Next, we will add a hard constraint to remove candidates that do not match an essential property. This snippet enforces a must facet to constrain candidates by lang. It demonstrates how a must facet acts like a gate. Candidates that do not satisfy the facet are excluded from scoring entirely. In the example, the code filters documents by their language attribute before the lexical ranker runs. Key parts are the facet predicate that tests the document attribute, the application of that predicate to the candidate set, and then passing only the surviving docs to the scorer. The important trade-off is obvious. Must facets guarantee compliance, but they can reduce recall. If you need broader recall, you relax the must or move the constraint into a should. Now we will nudge scores rather than remove candidates. This snippet adds a should facet boost that nudges but doesn't filter. It shows how to compute a secondary signal from a facet and convert it into a score multiplier or additive boost. The code evaluates the facet for each candidate, computes a boost weight for true values, and combines that with the lexical score. The snippet highlights a tunable boost parameter that controls how strong the nudge is. Increase the boost, and matching facet values will float to the top more often. Decrease it, and the text relevance dominates. This pattern preserves recall while guiding ranking toward preferred attributes. Next, we will combine the two ideas and limit runaway boosts. This snippet combines must filter with capped should boost to limit bias. It shows how to apply a must facet first to remove disallowed docs, then apply a should boost with an explicit cap so the boost cannot swamp the text score. The key lines include the must application, the boost calculation, and the cap enforcement, where the boost is clipped before mixing into the final score. That cap is an important knob. Low cap keeps results text-driven. High cap gives more power to the facet. Use the cap to prevent a small facet signal from dominating results when you still want textual relevance. Now we will blend textual relevance and facet signals in a controlled way. This snippet mixes text and facet signals with a tunable alpha-beta blend. It implements a final score as a weighted combination of the lexical rank and the facet-derived boost, where alpha controls the text weight and beta controls the facet weight. The code first normalizes both signals so they are comparable, then applies the alpha and beta weights and sums them for the final ranking. The adjustable parameters are alpha and beta and the normalization method. If you raise alpha, text relevance wins. If you raise beta, facet signals dominate. Proper normalization and a small validation set make choosing alpha and beta straightforward. This small example maps directly to a real system. Replace the toy docs with your catalog. Use the same must rules for legal or inventory constraints, and expose boost and cap as feature flags or parameters in your ranking service. The same alpha-beta blend works with dense encoders or with an ANN index. If you swap the lexical scorer for a vector score. Recap. Must, should plus facets means force the rules you cannot break, nudge everything else, and control the nudge so it does not overwhelm relevance. Use this when you need firm constraints and still want personalized or business-driven ranking. Caveat: too many or too strong boosts will hide true relevance. For one next step, tune the alpha and beta weights on a small labeled set or shadow them in production, and measure both relevance and compliance metrics as you adjust. If short, practical IR helps, subscribe and watch the IR videos.